Yeah, hi. This is Peter Mooney. I'm a student on HDIP course there in DKIT. Um, this is a CA1 for integrated healthcare software systems. We just have a problem definition here first for the product that we've chosen to improve for our database. The dental heart monitor is a device that is used by ordinary people who are experiencing difficulties with their heart. It is attached to the patient who then wears it for 24 or 48 hours. The information is then recorded by the doctor and medical technician at the hospital to decide if the patient needs further treatment. When the patient is wearing the monitor, they need to keep a diary of the movements and activities. The patient has to write down any feelings they're having, such as out of breath, dizziness, sweating, pains, and so on, at the time they occur. While the heart monitor records the information from the heart and the body, the patient has to record all the information on a piece of paper and hand it to the technician in the lab when they hand the monitor back in. This is the problem that we have identified to be changed. We feel that the information written down on a piece of paper could easily be stored on the monitor by using a simple database. Now, a couple of user stories here from our own personal experiences. Kevin, the other guy on the team, had to use a heart monitor a couple of years ago, and this is where we got the idea from. I also have, both my father and my sister survived heart attacks a few years back, and they had to wear the monitor and record their activities for 48 hours and record their activities on paper. A friend of mine also wears a heart monitor under his skin, and in the house he has a device fitted to the wall that scans the data and sends it to the Mal hospital every evening. I also spoke to a medical secretary who works for a doctor's surgery in town. They both think that this would be an excellent idea. This is some of the benefits now for both the patient and the doctor. The benefits to the patients are they don't have to worry about leaving the sheets of paper at home when they visit the doctor. They're also given access to the information whenever they want it. The information would also be sent electronically to the lab along with the results of the heart monitor. The benefits to the technicians, the doctors and the hospitals are numerous, the biggest being the costs, greater efficiency and accuracy of storing information, and less work of recording the information twice. And how could it be used in other areas? I also spoke to a friend of mine who was a personal trainer, and he thinks it would also be very useful in the leisure and fitness industry, where people who are in training for events could log their information with the gym. It would also support other organisations like Weight Watchers and Unislim. I just want to go through a little diagram that we have here now for a UML for our database. Okay, so you start off here. You have a list of patient names. Just in this one, this table, there's a small table: patient ID, patient first name, and the patient last name. Down here in this one here, we would have the doctor's name. We have a doctor ID, the medical centre, the doctor's first name, the last name, and the doctor's email address, or phone number. This is linked then into patient visits to the cardiac centre. See this? In here in the patient visits, you have to visit the visitor ID, the time that they arrived, which doctor it was that would have sent them, their own ID, and then you'd have a visit date and any comments that they would leave. Also in the cardiac centre, the unit ID, cardiac unit, doctor ID, and the patient ID and contact numbers. See then if you just go back up here, the way the patient names, the way it's all linked in, all the different tables are linked into one another. Again we have the patient names. Here we have the patient records. And in the patient records you just have some of the same stuff again. Patient ID, an update, first name, last name, patient complaints, patient medication, and any comments that the patient would have. We're also looking at the patient's diet, what the patient would be eating, and what if they were having any symptoms, would have any effects on any symptoms that they would be feeling during the day. You'd have breakfast, lunch, and dinner, and any snacks they would be having during the day, and what kind of food they were eating for each meal. Also have down here then is patient symptoms. And that would be simply any symptoms that the patient is feeling, as I spoke about earlier, whether it would be any out of breath, sweating, um, low energy, all that kind of stuff. And up here then in a separate table, if a patient was recording down here they were suffering from pain, you would have a pain severity level. And then we would just have like the patient severity level, the patient ID, a log ID, what time they were logged in, and the severity of the level of the pain. In this one there, you say that if you're given a 7 to 10, it would be for a very high pain, severe pain. We would give it maybe 4 to 7 for medium kind of a pain, and then 1 to 4 1 to 3 for any low kind of pain. That would give the doctors and the people at the cardiac centre any information they need, whether they would need any further treatment or medication or anything like that. And this here is the bit that we were speaking about earlier on. It's the bit that's currently done on paper, and that would support the rest of this system here. Currently, the way it works is the patient wears the heart monitor and given a piece of paper to fill in. This one here did have a diary with a monitor ID number, a duration of the time that they were wearing the monitor, the start date, and the day it was due back. And over in this one here then for the activities, you would write in anything that they were doing during the day. You would have a log ID, what time when they logged in. You'd have a symptom ID if there was any symptoms, if there was any pain. You have a diary ID, which is this one here, and you would have an activity ID, whatever activity they were doing, whether it was strenuous, whether they're going for a walk, or anything like that, whether they were doing housework, or whether they were just doing no activity at all and just sitting in the house. The next one I'm going to look at is the database itself. So you see here now where we have a list of patient names. It's in there, and a list of patient IDs. Okay, now let's go down to the user login one. Now, in order for a patient to log in, we still have the patient names in here in the patient name table. And the user could be a patient, it could be a doctor, or it could be a technician. Okay, so we have up here doctor names. We don't have a technician table just at the moment, but you can see all the other ones there. You have the patient diary, the patient diet, patient names with that, patient severity level, patient records, patient symptoms, and number of patient visits. And this one up here would be the cardiac centre that they visited. This could also be linked in between one or more cardiac centres. Each patient would have to have a login details, have to register with the system and log in. And this is what to be given. You'll be given a user ID 1, 2, 3, 4, 5. And would have to be asked to enter the email address, then put in the first name or the last name. And when they would be doing this, or depending on what it would be, the patient, doctor or the technician, be given an access level. Now obviously the doctor would be given a greater access level than the technicians or the patients. Now just go back in, just go in and have a look at the code. Okay, now this is the code. The code was giving me a bit of a few problems, but if you just scroll down here through it, okay, you can see where we're putting it in, or it's connected up to the the SQL database by this little feature here. And in there, then you have your login and your insert into the tables. And in here we just have a few while loops and if else statements. If you just go through this one here, okay. So yeah, a patient will be asked to register with the system. Just be asked to press number 1 to register with the system, or to be asked to press number 2 to log into the system. So this is just a wee if statement. just if statement to see what happens when it goes on in here. So the patient will be asked to enter number 1, right? You have to log in to register onto the system. Okay, now, so you're asked to enter their email address, and then select from users where email address is whatever the email address is. Okay, so that's what this statement is here. Enter the email, and then the result would come back with a statement. Now, if the statement is true, we're saying you have access to the system and your access level. I would say please choose from the menu list below. Now, you'll be asked to enter the patient's name. If it's number 2, be asked to after the second one, we asked the patient's a list of patient names. And what will happen is then to be given if it's number 2, the user wants to view a list of patient names. But it's select from the patient names, and we'll be given a patient ID, a first name, and a last name, and this will come up on a drop-down menu. And while this is running, it will print out these results. Alright, you'll be given, sorry, the email address that you have registered up here will tell you that it's invalid, that you're not logged into the system. So what you'll be asking is to register. Your email address is not registered. So we have to do is register into the system. So we have a number of print line statements. Please enter the doctor's last name. Sorry, this is the wrong. I'm going to a wrong table here now. Back up here. You asked to put in their name and the login details. Then be given access to the system. Now, if it's the doctor that logs into the system, if you go through the same process again. So here we are now with a different table for the doctor. Please enter the doctor's last name. Please enter the doctor's first name. Please enter the doctor ID, and insert into the doctor's names. With the last name, the first name, and the doctor's ID, and a number of values. And in here we're putting in 3 values. See that these little question mark things here. And in here then you have the statement from the set string. You see that there. It says to insert into the doctor the first name, the last name. And this is what will be coming up. You enter 1 for the doctor's first name. Hit enter, go on to the next name. Enter the last name, enter the doctor's first name, then enter the doctor ID. And here we can select our query. See, these will be prepared statements. Select from the doctors from the list of doctors' names, and you'll put it in here. The result, the last name, the first name, and it will show you here while all this is going on. The system will print out the result of string 1 with string 2, with result 1 of string 2. Get the doctor's name, the doctor's first name, last name, and his email address. And this would then come on and link into the next, which will be the cardiac center. If you ask them to enter for details, you might be asked to enter the same details for the doctor ID at the cardiac center. Okay, now I'll show you something here now, because we spoke to you this at the weekend that I wasn't able to get this running. I have a wee problem over here with my directory. I'm getting an error message. You can see as you scroll through the file, I don't have any red lines or anything like that in here. Okay, that just tells me that that the code is fine and it should run. The problem I've been having is a problem over here with the directory. So I'll just click this and run the file. I'm coming up with this error message here. This tells me that it can't find the class, which is up here. Yeah, which is the public class for the name of the MySQL and for the name of the thing. So okay, so I was just having problems with that. So that's why I can't show you how it inserts into the database. Okay, so that's just my presentation done, and hope to talk to you next week, and bye bye.